Today we want to look at the sum and difference formulas for the sine, the cosine, and the tangent. When I say sum and difference, if you add two angles that you're familiar with, or subtract two angles that you're familiar with, those special angles that we know from the unit circle. If you were to put in your calculator, in your y equals the sine of x plus 3x, and then in y2 put the sine of x plus the sine of 3x, you'll see that the distributive property does not work because you do not get the same graph. You get two different graphs. So we have some formulas that would allow us to add these two angles together or subtract the two angles. For the sine, and I believe your book uses u plus v, the formula is the sine of u times the cosine of v plus the cosine of u sine of v. Move that over a little bit so you can see it. If we have the sine of u minus v, that becomes the sine of u cosine v minus cosine u sine of v. And yes, you do need to know these formulas. For the cosine, notice with the sine, if we're adding, we add in the formula. For the cosine of u plus v, we have the cosine of u times the cosine of v minus the sine of u sine of v. And for the difference of the angles, we have the cosine of u cosine of v plus the sine of u sine of v. The more times you write these formulas down, the easier it will be for you to remember them. And then we also have formulas for the tangent of u plus v. This is the tangent of u plus the tangent of v over 1 minus the product, the tangent of u, tangent of v. And then you might be seeing some patterns here as far as the pluses and the minuses. This would be the tangent of u minus the tangent of v over 1 plus the product, tangent u, tangent v. Now I could use these formulas. Remember, we have to get those angles that we know, pi over 6, pi over 3, pi over 4, those angles from the unit circle that we know in order for this to work. So let's say that I wanted to find the cosine of pi over 12. Now I don't know what the cosine of pi over 12 is. But if we think about those familiar angles, I'm going to write them down here. We say we've got pi over 6, pi over 4, pi over 3. If I were to convert these to twelfths, 6 goes into 12 twice. We get 2 pi over 12. Here we get 3 pi over 12. And here we would have 4 pi over 12. So there are some different ways that we can combine these angles to get pi over 12. We could take 4 pi over 12 minus 3 pi over 12, or we could do the cosine of pi over 3, which is 4 pi over 12, minus pi over 4. Looks like you could also do pi over 4 minus pi over 6, but let's just keep it as the cosine of pi over 3 minus pi over 4. Well, if I use the formula, this is the cosine of pi over 3, cosine of pi over 4, plus the sine of pi over 3, sine of pi over 4. Now these are all values that we know. The cosine of pi over 3 is 1/2. The cosine of pi over 4 is the square root of 2 over 2. Plus the sine of pi over 3 is the square root of 3 over 2. And the sine of pi over 4 is the square root of 2 over 2. So if we multiply, we get square root of 2 over 4 plus the square root of 6 over 4, and we have a common denominator. You could leave it like that, or you could write it as the square root of 2 plus the square root of 6 over 4. And you could check that on the calculator to see if you get this. If you plug this into the calculator and got a decimal approximation, you could compare it to this and see if you get the same decimal approximation. That's one way that you could check that. Okay, let's look at the sine of 19 pi over 12. Now, I don't have enough to add up to 19, so let's keep going. If we do 2 pi over 3, that's going to be 8 pi over 12. If we do 3 pi over 4, that's 9 pi over 12. If we do 5 pi over 6, just going around the unit circle, change into 12ths, that gives me 10 pi over 12. And so now I can see how I could come up with 19. So we could rewrite the sine of 19 pi over 12 as the sine of 3 pi over 4 plus 5 pi over 6. Now addition is commutative, so it doesn't matter about the order that we put it in. Now again, I would use the formula as you write it out. The sine of 3 pi over 4 times the cosine of 5 pi over 6 plus the cosine of 3 pi over 4 sine of 5 pi over 6. Now we know that in quadrant 2 the sine is always positive, so the sine of 3 pi over 4 is the square root of 2 over 2. And the cosine of 5 pi over 6, cosine's negative. The cosine of 5 pi over 6 is going to be a negative square root of 3 over 2 plus a negative square root of 2 over 2 times the sine of 5 pi over 6 is a positive 1/2. So if we multiply here, we get negative square root of 6 over 4 minus the square root of 2 over 4. You could write it as a negative square root of 6 minus the square root of 2 over 4. Or you could factor out a negative and have the square root of 6 plus the square root of 2 over 4. Just as a reminder, that would be the answer for the sine of 19 pi over 12. If I were to take the sine of 3 pi over 4 plus the sine of 5 pi over 6, we'll see the sine of 3 pi over 4 is the square root of 2 over 2 plus 1/2. That does not equal what we got when we use the formula. Those are not the same, so you cannot use the distributive property. We have to use the formulas that we've talked about. Now we can do the same thing if we're working in degrees. Say I want to find the exact value of the cosine of 75 degrees. We've got to use angles that we are familiar with, and we know 30, 60, 45. So we could rewrite the cosine of 75 degrees as the cosine of 45 degrees plus 30 degrees. All right, if we're going to use the formula, the more you write it out, the easier it's going to be for you to remember it. The cosine of 45 times the cosine of 30 minus the sine of 45 sine of 30. All right, the cosine of 45 is square root of 2 over 2. The cosine of 30 is the square root of 3 over 2. Notice these numbers keep popping up over and over again because these are the angles we know. Things that are going to change is whether things are negative or positive. Minus the sine of 45 times the sine of 30. So we get the square root of 6 over 4 minus the square root of 2 over 4. Or you can make it one term since it is a common denominator. If we wanted to think about the sine of 105 degrees, well, if angles we know, if we subtracted 60, which we know from 105, we would get 45, so we can use 60 plus 45. You could use 135 minus 30, but let's try 60 degrees plus 45 degrees. That does give me 105 degrees. So we would have the sine of 60 cosine 45 plus the cosine of 60 sine of 45. And the sine of 60 is the square root of 3 over 2. The cosine of 45 is the square root of 2 over 2. The cosine of 60 is 1/2, square root of 2 over 2. And I think you can see you get the square root of 6 plus the square root of 2 over 4. Okay, we're going to change thought here just a little bit. I want to find the exact value of the sine of u plus v. Now, we haven't done any with the tangent, but you just apply into that tangent formula just like you apply into the sine and cosine formula. I want to find the exact value of the sine of u plus v given that the sine of u is 4/5 and u is between 0 and pi over 2, first quadrant, and given that the cosine of v is equal to negative 12/13, and v is between pi over 2 and pi. All right, the formula says I'm going to need the sine of u, cosine of v, plus the cosine of u, sine of v. Now, I don't have the cosine of u, but I can find it. We can use our Pythagorean identity, or you may think about your right triangle real quick. That does make you use the Pythagorean identity. If this is the angle, the sine is 4 over 5, and you should hopefully remember that this is going to be a 3. We're in quadrant 1, so the cosine of u is 3/5. If we think about this angle, and the cosine is 12 over 13, we know that this side is 5, Pythagorean triple, so the sine of v is equal to 5/13. Okay, Now we plug those values in. It's not the sine of 4/5, it's just 4/5 times the cosine of v, which is a negative 12/13. The value, not the cosine of negative 12/13, plus the cosine of u, which is 3/5, times the sine of v, which is 5/13. Here we get negative 48 plus 6/65 plus 15/65. So we will get a number that we can deal with, negative 33/65. That is the sine of u plus v, negative 33/65. Okay, let's do another one in this vein. I want to find the sine of u plus v given that the sine of u is 5/13 and the cosine of v is negative 3/5, and we're in quadrant 2. We'll just say quadrant 2 for both of them. Okay, so if the sine of u is 5/13, the cosine of u is negative 12/13. All right. In fact, instead of doing the sine of u plus v, why don't we do the cosine of u minus v, just to use a different formula. Okay, so if I know the sine of u and the cosine of u, the sine of v in quadrant 2 is positive, and it's going to be 4/5. So we're working with the cosine. The formula is the cosine of u, cosine of v, plus the sine of u, sine of v. So we're going to have negative 12/13 times negative 3/5 plus the sine of u is 5/13 times the sine of v, which is, put my v right there, 4/5. Now it's just a matter of multiplying and adding. 36, we're going to have the same denominator, plus 20 is 56/65. One last thing, I want to use my identities to prove that the cosine of pi over 2 minus x equals the sine of x. This is an identity that we have worked with, but now let's use the addition and subtraction formulas, the sum and difference formulas, to actually prove it, algebraically. So we know that we're going to have the cosine of pi over 2 times the cosine of x plus the sine of pi over 2 sine of x. The cosine of pi over 2 is 0, and the sine of pi over 2 is 1, so the sine of x equals the sine of x. And that's a way that we can prove that identity. We could do the same thing. Let's say that we had the sine of x minus pi over 2 equals a negative cosine of x. And I want to prove, using the sum and difference formulas, that this identity is true. Notice it's x minus pi over 2, not pi over 2 minus x. That's why it's the opposite. Okay, so we've got the sine of x cosine of pi over 2, just plugging into the formula, minus the cosine of x sine of pi over 2. And the cosine of pi over 2, again, is 0 minus the cosine of x times 1. So a negative cosine of x equals a negative cosine of x. And there you have it.